Welcome to the Prosthetics and Orthotics podcast with Brent Wright and Joris. Hello, everyone. My name's Joris, and I'm here with Brent Wright on the Prosthetics and Orthotics podcast. And, this is a journey. And Brent Wright is really full into this journey of digitizing prosthetics and orthotics. And he's trying to help people do that. And I'm a 3D printing consultant, and I'm very interested in this part of the business. And we're both kind of interested in saying, you know what, is 3D printing going to be the default technology for a lot of prosthetics and orthotics? Is it going to be just a phase? Is this whole digital revolution going to define how people have even more enabled lives in the future with prosthetics and orthotics? Or is it a false hope? And we really don't know the answer. Neither of us know the answer, and that's why we're doing this journey and trying to talk to people who are also in the digitization of prosthetics and orthotics, and trying to figure out what's happening, what's going on the floor, on the factory floor here, and in podiatrist offices and in software companies to try to figure out what's going to happen. So today, we've got a special guest, and it's Mike Gorski, right? So Brent, tell us a little bit about Mike.
Yeah, thanks, Joris. I am super excited to have Mike on the show. You know, Mike's been a big part of the journey for me down the 3D printing path, so to speak. And he has really pushed the FDM technology, starting with his high flow stuff. But we've known each other for a good long time. I think I was one of his first original buyers of his printer kit. That was something to put together. But it's still running, Mike. So I can tell you that some good things are still rolling. So I appreciate you being on, Mike.
No, thank you. Thank you so much for having me. I really appreciate it. And Brent, thank you as well for everything you've done for Filament Innovations. I'm sure we'll talk about it more in the podcast to come, but you've been an integral part of Filament Innovations here and us growing as a company as a whole, and just being a great friend. So honestly, I can't thank you enough for everything you've done for myself and the company.
Yeah, this is going to be a good one, Joris.
Okay. That's good. So Filament Innovations, I know a little bit of, because I heard some people rave about it. And they make, basically kind of very industrial, quite large FDM systems that are just keep on ticking kind of machine, right? Mike, is that kind of how you'd be comfortable in that, or?
Yes, I would say that you're 100% right. So over the years, we've kind of established ourselves as an American-made company of FDM and FGF machines. Recently, FGF with the Pulsar. We have an amazing relationship with Dies Design, and so we're using the Pulsar for FGF, the Typhoon for high-flow filament extrusion, as well as the Pro Series for high-detail 1.75 millimeter extrusion. But our angle is it's an American-made machine. It's very high quality. We target businesses who are looking for professional FDM, professional FGF, but maybe don't want to spend $250,000 on a machine that is capable in terms of what we can do. So we're trying to build great machines at a great price with great customer service.
Okay. First, a little bit of a moment here to talk about Dies Design, because I love those guys. I love the nozzles, by the way. They're really high quality equipment, and that's like your only Canadian made part of your printer. It's a Canadian company, and they're just a bunch of great guys. I keep meeting up with them at Forum Next and stuff. They're just great guys, really down to earth, really straight shooters, and they make incredible gear.
They do. Not to get too personal here, but I do have an amazing relationship with them up there. I am good personal friends with Simone Duchesne, the CMO, and Felipe Carrier, the CTO. We're great personal friends outside of out of manufacturing, just like Brent and I became great friends. So they're great people. Like, I can't speak highly enough for the quality of their products.
Yeah. So Mike, a little bit, you're clipping a little bit, so you might be a bit close to your microphone there. But apart from that, everything is going well.
Okay.
So yeah, I love Dies Design. I love their nozzles. I love that they can print so accurately, and also like they're really meant for really productive printers as well. And that's a key part of the Filament Innovation story, right? Because you guys are all about this high flow stuff. Could you tell us a little bit about that, what that means?
Sure. Yeah. So the way we look at high flow, we actually got into the world of high flow probably, I'm going to guess 2017, 2018 off the bat. It was actually kind of two things came together to make this happen. One was working with Brent and prosthetics and how do we make them faster. And then the other side was I got an email from from Dice Design, Phil, regarding the Typhoon high flow system. So I'm guessing 2017, 2018 here is when this all came about. And I was talking to Phil about this from Dice, and I said, this could change the prosthetics game. I said, could I be involved more instead of just a beta tester per se? Like, how can I get involved in this design? Because what I'm seeing with high flow here, the capability to output, almost 2 pounds of plastic an hour from FDM was really just mind blowing to me. I'm like, how is this possible? Like, this is almost near pellet extrusion performance. And I looked at it where in the sense of everything kind of came together. Brent was telling me, how can we make these things faster, higher quality, make the socket stronger? I see Dice Design creating this high flow filament extrusion system because for me, I think filament is the way for the prosthetics and the orthotics market because just filament-based systems are so much easier to use than a pellet-based system. I mean, sure, pellet-based, can be cheaper in the long term. We can talk about that, of course. But having an easy-to-use high-flow system, almost 2 pounds an hour, combined with Brent's view of the industry and our desire to just build the best machines we possibly can here at Filament Innovations, is kind of like this triangle came together. And we're like, oh my God, we can put out 2 pounds filament an hour. And now we can use that to make prosthetic sockets in, say, roughly 60 to 90 minutes. So for us seeing high flow, we thought that was the future. We really focused on the Typhoon with Dies. I mean, the guys up at Dies kind of joked that Filament Innovations had a small hand in designing it because of all the feedback we gave them. We tore the thing apart since we got our beta model and everything we did to help them with. And that's why when we actually get our Typhoons from them, they laser engrave our logo on the front kind of as a little thank you for all the work we helped them do to design it in the beta stage.
I love those guys, dude. I love them. And so high flow, like 2 pounds of plastic sounds a lot to us from a 3D printing person, but maybe not so much to somebody who's less familiar with 3D printing. I mean, what's the difference compared to like just a regular kind of like FDM printer, let's say?
For a regular FDM printer, I would say with the Pro Series, for example, which Dies has, I've never actually bench tested the Pro Series, so I don't want to say this number is completely accurate, but I would say the Pro Series probably roughly 200 to 300 grams per hour it can probably put out, versus where you have the Typhoon putting out almost a kg an hour. So kg, roughly kg, but I mean, we're looking at, compared to some hot ends, almost 10 times the output of just plastic. It's just crazy. But I always tell people we want to be honest here with how we do this, and high flow printing is not for everybody. We still have customers in the manufacturing scene who want super high detail, very crisp prints. And I tell them this high flow is not for you. It's not, because you will lose some detail. You'll have some retraction settings, some ooze settings. And granted, Dice has done a great job to control that. I mean, you're not going to be able to get a 0.2, 0.4 millimeter nozzle on a Typhoon. The lowest it starts is 0.6. Doesn't mean it's not capable for high quality printing, but where I'm going with this is for engineering customers where tolerances are extremely important. It's not the system for them, but fortunately for us, more in the prosthetics market where we just need a large object done quickly, where say we don't need to be in a 50 micron tolerance, for example, that's where it really shines. It really hits home.
Yeah, because the tolerances are, we talked to some other people, the tolerances are enough for this, like just a little bit for people who may be a little bit not in the know yet. I mean, FDM is just fused deposition modeling. It's the original Stratasys term for their technology. Other people call it material extrusion or FFF, which you should never use because it's stupid. But anyway, but these are just any kind of extrusion technologies. And usually the idea that is around a filament. Then they have FGF, which is also mentioned, fused granulate or fused granulate extrusion, let's say, and that is just where instead of using a filament, so a wire of plastic, you use the granulate, which is actually a precursor material to the wire, and so typically that would be like, to set you back, like, let's say $6 a kilo instead of $20 a kilo. So that's a significant savings for a lot of people. Usually then you can extrude a lot of material in one place, let's say, but it's more difficult in movement speed, or, well, depend. There's also trade-off for using granulate, right? And so those are kind of like the semi-technical or semi-3D printing terms we've kind of talked about, that I just wanted to point out a little bit. And then just give us a little bit about, like, because like made in America sounds kind of, yay, good, but maybe also expensive, right?
Yes, it is. And that's where we try to take, because my background actually is not in additive manufacturing. I've been involved in other industries, running other businesses before I started Filament Innovations. So made in the USA, I love it. A lot of our components are made here in the USA, but there is that trade-off that people unfortunately see, where made in the USA is more expensive. So what I'm trying to do is kind of lean on what I've done with other businesses and other industries I've worked in before I got into Filament Innovations, and keep our overhead low, use a just-in-time inventory system, negotiating with our vendors here in America as well as in Canada with dies, to make sure we get the parts we need, we keep the overhead as low as possible, and we price our machines where we feel is an affordable and attractive price for other companies to purchase them. So we're not out of the ballpark for the businesses we're trying to go after. We're trying to make these affordable, but also at the same time, we can't price ourselves too low. We're not looking to compete directly with machines imported overseas. That's not our market. We're trying to have our own niche market here, where it's an American-made machine, it's high quality, and it's affordable, and we're just trying to deliver the best product we can.
Okay. And what are the kind of, like, if you look at the ticket, if you look at the purchase price of these machines, what are we looking at then?
So our Icarus high flow machine with a Typhoon is $31,000. We do have a new platform coming out this summer called the Aries platform. The Aries platform will have a 950 by 950 by 900 millimeter build area, and that's going to be our a la carte type machine that we're going after, where you'll be able to customize that with a Typhoon high flow system, or a Pulsar, or a heated chamber, or a G10 FR4 build plate. Maybe you want an IDEX dual extrusion system. So that's what we're planning for the summer. And then we also just recently launched our large scale Gen 2 Poseidon platform. We actually just shipped our first one last night, actually. We just finally got out the door at 6 o'clock last night. It's a 1400 by 1000 by 1000 millimeter build area, Typhoon and Pulsar pellet printing system. So high flow FDM as well as pellet FGF printing. And that's priced at $125,000 shipped.
Okay, that sounds expensive, I think, but that's kind of for, I guess that would be for like mold tooling and stuff, like a bit larger kind of applications, right?
Correct.
Yep. Yeah, and that's a massive build
that's
volume.
That's massive. Yeah, so 1400 by 1000 by 1000. I can go into the details, but it's a very high end machine where we're trying to go after. I don't necessarily want to say our competitors on the market, but there's other competitors offering very similar machines that are twice the price, some even 3-4 times the price of what we're offering at $125.
Yeah, it's interesting. I think I look as a consultant. I look at the market. I mean, we see a lot of large format players like Cincinnati, Thermwood, these kind of guys making like really large systems, like several meters in length, and these are made for, like, let's say large aerospace tooling, or parts for drones, or parts for like mini subs and stuff like this. Like mainly defense, right? Or defense or large industrial. And then we see what we call the medium format market. That's around a meter by meter by meter. And then we're seeing a lot of tooling. We see some players there, but it's not a battle that's been won by anyone, by any means. It's still quite open. Right.
Yes. Yeah. And so we're positioning the our Gen 2 Poseidon where we've seen it. We've actually sold a few of them already. And our immediate feedback is that we are priced low compared to other people. But that's just feedback we've received. Where when people see the machine in person and see how we've seen our competitors' machines in person, the fact that we're using all enclosed ball screws, fully enclosed print area, closed loop stepper servo, but yet we're still using the Duet ecosystem, so Duet Wi-Fi, RepRap firmware can still be customized. They're like, wow, this is a heck of a machine.
Nah. So the ball screw, you've included closed ball screws. Like, talk me through. But that's okay. That means a lot. That means something to me. But that just means that's the screw that keeps the lowers and lowers and raises the platform. which is a big stability thing, and you can put 2 to 4 of those, or maybe even more on a build platform, right? So what's that mean as a quality signifier to you? Let's say.
To me, it's a quality signifier because one thing we've seen with pellet extrusion is that you have to enclose the linear motion system. That's what we've seen. And the reason being is we've immediately ran filled filaments, carbon fiber filled, fiberglass filled, resin, and that dust gets everywhere. So immediately we said that this is going to destroy the linear motion system if we don't protect it. It has to be protected.
If you start printing with ABS, right, or even to a lesser extent ASA, which is a related material, ASA, and definitely if you start making very large things, like several meters of stuff, you're going to have to control the temperature in your chamber. And even then, a lot of times really large objects will then buckle or bend or just generally deform. And especially if you use certain polymers. And then, so the way to circumvent this is to have a short carbon fiber. So a carbon fiber of, let's say, a centimeter or something like this, or less, into your material to give you added stiffness, and also make it so that your object is far less able to warp, let's say. And so that's why, like, if you make quite large objects, for us, quite in the 3D printing industry, it's like anything above 20 centimeters large, which is ridiculous. But anyway, then you start coming into these problems, and then that's when your enclosed linear rails, linear stages is kind of important, right?
Absolutely. Yes. You nailed it 100% on 100%. We actually, we learned this when we built a machine last year called the Kraken, and we had 12 weeks from design to shipping. It took us 12 weeks to design, source, build, stress test, and ship a machine that had a 4x8 by 4 foot build area. And one of the things we realized during stress testing, now for this point, we could not get ball screws the size we needed. So we had to go to a high-end belt-driven system on rails for this one. But we learned as we would print with carbon fiber reinforced material, the dust would go everywhere. And that's where we got the idea of where we have to, for our next generation of machines, which now we're currently in, we have to enclose linear motion system, or we're going to see some of that carbon fiber dust or fiberglass dust that's infused in these pellets as they're being fed is going to get in the machine, and it's going to ruin the linear motion system. So that was one of the big reasons that pushed us to go to a fully enclosed system.
Okay. Which also is really interesting because it could maybe allow you to tackle higher temperatures as well, right?
So yes and no, because it's not it's not insulated. So you will get a little bit extra, I'll say, degrees where you could heat the chamber up to, but nothing crazy. The heated chambers that we're looking at doing here on our systems, we're shooting between 50 and 60 degrees Celsius. Because what we found with the manufacturers we work with, as soon as we hit the 65, 70 degrees Celsius ambient temperature inside the chamber, that's where we're starting to get in the grounds of parts failing. So we're end stops failing, motor steppers overheating. So we're aiming
any circuit board, right? Yeah, any circuit board will die on that.
Exactly. So we found the sweet spot for our printers with the heated chambers between 50 and 60. After that, it's almost for the whole machine. Either parts have to be insulated, water cooled, or we just need to buy parts that are designed for high temperature printing.
Yeah. Okay. So just to give people a little bit of a flavor of this, like a normal desktop FDM material extrusion printer operates at, well, we say 208, but a lot of people will print at 220 or 230 on a material such as PLA or something. If you want to, PLA is a tough, surprisingly tough, the kind of the everyday material of 3D printing. If you want to get into higher performance materials, you're either going to have to work with a chamber that reduces heat bleed, or keeps the temperatures constant, which you would need for ABS, for example, or you're going to have to keep your very filament dry. And then you work with nylon or polyamide materials, which are also very strong, but then you're going to have an increased nozzle temperature. You're going to need about 300 or so C, right? And then you're going to have to dry the filament because the nylon will attract water like crazy. Then on top of that, if you want to go even higher, you're going to have to want to do something like PEEK, material called PEEK, polyether ketone, which or PEAK, which is a family of materials that are similar. And then you're going to need nozzle temperatures of 420 degrees, and you're going to need a bed temperature of 100 to 200 and a chamber temperature 100 to 200. So on the final iteration, this really high temperature thing, you're going to have to insulate everything, and you have to completely keep your chamber clean. Meanwhile, if you've got the nylon, you can kind of go in between-ish, right? But you need to harden some things. You need to have more expensive materials to make that work, which pushes the cost of the printer up. And you're going to need to keep like circuit boards away from the main build chamber. And meanwhile, if you do a normal printer in ambient air, well, you'll get great results as long as it doesn't have to be perfect. So that's a little bit of a background for the people that are a bit new to the printing element right there. But Mike, so what are you guys? So your sweet spot? You say you're doing 60C, right? 50, 60C to keep it up. But are you focusing on nylon or not really? Or?
Not necessarily right now. We're actually focusing on a new material that we're getting ready. Well, we technically brought to market a few weeks ago, but we haven't done a lot of marketing behind it yet. Is a CPX material, we're calling it, which is a high impact polypropylene material that was designed just for the prosthetics market. And so, I'm sure Brent would like to talk about whenever we get there to the how the prosthetics and the sockets and material advancement on that point. But we're hoping from the prosthetic side right now, PETG is kind of your go-to material for check socket, and we're trying to find the next material after that where patients can walk on 3D printed sockets without needing reinforcements. And I'll leave the technical stuff to Brent as far as the prosthetics is concerned. I'm not a prosthetist by any means, but I've learned a lot through him. And so we're hoping that this new polypropylene material that we developed with prosthetists in mind, and they've actually given us feedback on it, will help us use high flow FDM 3D printing with our machines to actually make prosthetic sockets that people can now walk on without needing additional reinforcement or worrying about it breaking.
Yeah, because I still think it's bizarre that everyone uses PETG, by the way. But it's like, what? Why? Because everybody in the desktop market uses it because it's shiny, essentially, and because everybody's worried about running out of PLA, right? That was the reason why PETG became like a thing.
Well, one of the things for like the prosthetic market that is always interesting to me is people want to, see through to the socket or the socket to see how the fit is. But in the same way, though, the funny thing is you typically will have a 3 millimeter or a 6 millimeter gel liner that has a fabric cover on it. And I'm like, well, can you see through the gel liner? So does it really matter? And that's tongue in cheek. And I believe that. And that's why I think it's pretty exciting that Mike has moved on to this other type of technology, because I always, for my check sockets, I never did clear check sockets. I would always do a copolymer check socket, which has been notoriously hard to print. So, Mike, I wanted to hear a little bit about your journey iterating that material, and then did you find somebody to extrude it, or did you have to bring that in-house?
Yeah, so we failed a lot, actually. We failed. I have no problem admitting my shortfalls in life, and we failed quite a bit. So one of the things, if you don't mind, just to jump into CPX and a little bit what we did, starting last year, beginning of 2021, we were full swing with our machines. The Typhoons from Dyes are being produced. We're rolling out machines. We're selling PETG, great. We work with Mitsubishi Chemical Polymer Performance Companies. They're our material supplier. And it came to the point where, hey, this is great. We're selling PETG. We're making check sockets. Fantastic. We're selling machines. But immediately I said, this is great today, but this is not sustainable long term. This is not. I said, there has to be something better than PETG out in this world. So that kind of took us down the path of all of 2021, working with Mitsubishi Chemical Polymer Performance, also go by MCPP. What can we do to take this to the next step? And I actually worked very closely there at the time. Remco Katz worked there, and his family is actually involved in prosthetics and orthotics as well, I found out. And so it was kind of a personal project for him as well. And he helped us with numerous grades of polypropylene that was sent to us for testing. We probably went through about 15 different grades of polypropylene. And we also had pellet extrusion here at the time. So to cut down on R&D time, I would say to actually increase how fast we could do our R&D time, we had pellet extrusion on hand. So we started out with all these pellets, these polypropylene formulations. We're mixing some stuff here. We're taking some stuff directly off the shelf from Mitsubishi. And we're like, how do we do this? And we actually worked very closely with a local clinic here, Valley Prosthetics and Orthotics, owned by Stephen Chu. And he helped us R&D some of these new materials and test them out. And he's been a huge asset to us. He's our local clinic here. And Stephen Chu just really helped us out a lot in formulating CPX. So long story short, we go through all this R&D. We find a socket, that material that works. We go to get it extruded. And it turns out, unfortunately, MCPP at that time could not extrude it. And my heart just tanked. This was one of the biggest letdowns of my life, because I spent probably 8-9 months last year of just nonstop polypropylene printing materials, getting this stuff made. At the time, it was all in pellet form because we had pellet extrusion here with the Pulsar. Great, we did it. We found an extrusion grade plastic, and it could not be made. Unfortunately, all the trials at MCPP failed in this material we found. And this is one of the biggest just like shocks of my life. I was so sad. I'm like, we got to figure this out. We got to. So I went to my operations guy here, Steve, and he's been my best friend. So we've been 14 years old. I said, listen, man, I know MCPP has a lot more knowledge than we do. We've come too far. We need to buy an extrusion line and do this. And he's looking at me like, what do we know about filament extrusion? That's why we go to them. What do we know about this? And I'm like, listen, man, we got to figure this out. So we ordered a small lab extruder from China overseas, brought it in, and within about 2 weeks, we were able to crack the code on how to extrude it. There's certain modifications to the line, ambient temperatures, and certain cooling processes that we had to implement in our little line here in our shop to be able to make it. And the big news is, when we haven't announced this yet, that we were just in Ohio at the Bellevue MCPP plant last week. We shared our knowledge with them. We retrofitted one of their lines, and now they will be able to produce it in bulk for us, because it has to be extruded so slowly. And that's, we can, even on a high-end machine that can make 25 to 30 kg spools an hour, we can only make 4 kgs an hour of CPX material. It just has to be extruded so slowly. And that's on a professional line at MCPP, where, you know, they're used to just high volumes of plastic being extruded. But even with our modifications, we can only make 4 kgs an hour of this on one line. But it took us finding material through pellet. We're happy. We're on top of the world. The material works. And then we come crashing down emotionally because it couldn't be made. And then I just said, hey, we're going to figure it out. Bought our own extrusion line. Within 2 weeks, we were making filament with a lot of homemade modifications and a lot of trial and error. And now it's being made by MCPP in Ohio, just very slowly, but it is being made.
Wow, what a story!
And I love polypropylene because it's soft, right? That's one of the things. It's flexible, right? But it's also soft, and it's like ideal for braces and anything on the skin you have to wear.
Right, absolutely. And what was unique about CPX, we found out there's only one thing that will actually work with bed adhesion. The Magic polypropylene won't work. It actually will not adhere to polypropylene packaging tape, which we thought was weird, right? It's bonded to itself. It wouldn't bond. The only thing that worked, I'm not trying to plug their product, but just anyone who prints with CPX knows, it's the BuildTac polypropylene adhesive. That is the only stuff that will work on CPX, and it works amazingly. Not you know, I'm not trying to plug their material, but I'm saying that's the only polypropylene bed solution that we found that actually works with this.
And why is this material so great? What did you actually do? Is it the only that you made polypropylene work with high flow? Is that the main thing here?
It's that we're now utilizing this material for prosthetic sockets that can be walked on without needing reinforcement. That was kind of our goal, was to choose a material in 3D printing filament form to take prosthetic socket fabrication using FDM technology, utilizing high flow to that next level. And so what we did was, we talked to our local clinic here, and I said, you know, what do you use besides PETG? And, you know, working with Stephen Chu, he informed me that copoly is huge in the prosthetics industry. And so I'm looking at this from not only a business standpoint, but a 3D printing standpoint, saying, if we want to help push this industry forward, why am I trying to give them a material they're not used to using? Let's take the material that they're used to using, find the right grade of that material, put it into filament form, and then go on and do that. because we're already introducing a technology to prosthetists who aren't used to it. I mean, it's a digital fabrication. It's a whole new world. There's a lot to learn. So why would I want to just go and make their lives even harder with new technology by introducing a new material that they've never worked with? So our whole goal was take the materials they're used to using in sheet form, find the right grade, the right combination of that material, and put that into a filament form that would work for these sockets. And that's how we landed on a copoly polypropylene.
And how's that working out? I mean, how are the initial tests of that?
Really, we are very impressed. We were down at the Academy show down in Atlanta, Georgia 2 weeks ago, which is a large prosthetics and orthotics show. And quite a few of our customers who have our machines, who got early trials of CPX, came up to me, shook my hand, and said, "You did it. This is the next step. You did it," which meant a lot for me personally. And we're also not just back it up with kind words, because I am a man of numbers and analytics. We also have Sagar Shetty from Bionic Prosthetics and Orthotics. He actually just did a grant study with the Department of Defense testing 3D printed sockets. And one of the sockets that was tested was CPX. So he's getting ready to publish those findings of how CPX did in a prosthetic socket form. I don't want to give away the numbers. It's his study. It's a peer-reviewed study. It's going to be published hopefully soon. But from what I've seen, the numbers look really good. So we're very happy with it.
And of your machines, which one would be the one that you target much more to like an orthotist, let's say, or a prosthetist? What's the one that makes the most sense?
Our best-selling one, and with that focus, is the Icarus at $31,000. That's the one that we sell the most of for the prosthetics fabrication.
Okay, and so let's say I don't know anything. I know nothing, right? So I walk into your factory and make off with this printer. How am I going to get started? And what's the kind of like, what are the numbers in this thing? How am I going to like make it earn it back? Let's say.
Sure. So for example, so you come in, we would show you the machine, we would show you what it does. We actually just started working with a company called Prosthetics out of North Dakota. They're actually going to be our O&P training grounds for people who need training on 3D printing and on high flow extrusion. So Prosthetics will be offering that. But if you already know 3D printing and you're ready to jump in, you would come in. We have our manuals. We have some videos behind the scenes that we send to customers that show you how to 3D print, how to care for the Typhoon, how to level the bed, all your basic 3D printing stuff, right? But from a financial standpoint, this is kind of where the Icarus helps sell itself, because based on the volume of the sockets you're producing and how you want to bill back for these sockets to insurance companies, we show you where, hey, from designing and to printing, you could have a socket made in about 2 hours. So roughly for us to create, I'll say an average, and I know average is kind of hard to say, every human body is different, but the average, I'll say below the knee prosthetic socket, we can print in about 60 to 90 minutes. And so you take it, you would print it, do a little post-processing, clean it up, do what you have to do. About our customers have told us it's about 15 minutes of post-processing. And I say, here are the numbers. You can print and post-process. Well, let's just say 2 hours, easy math, right? Machine's got to heat up. You have to load the G code, slice and all that good stuff. But it's essentially your front to back switch on to prosthetic socket being carved, done in about 2 hours. So we never get involved in billing and reimbursement. We leave that to the customer. However they want to bill these things back to insurance companies for the prosthetic sockets, we don't get involved in that. But I said, what you can bill back at this. You made this socket in 2 hours. But not only did you make it in 2 hours, what's the opportunity cost? In that 2 hours, that machine running and doing its thing, now you just opened up that technician to go do something else, possibly see another patient, possibly do stuff around the office. So we're showing you how you're essentially freeing up other people's time while you're bringing in the machine, almost like an employee. So now instead of an employee do the fabrication, a machine is doing that fabrication, and now that employee just got freed up to do other stuff too. So not only do we explain the financial benefits with the insurance companies, but we also explain that, hey, now you can do other stuff with that employee where you have reduced labor and you have now value-added services. That employee's time is now freed.
Mm-hmm. Mm-hmm. Okay. So that sounds like a very positive picture. And do you have any, you mentioned there is some training available, but is there any kind of like guide to like, hey, like if I walk in today, what's the time it's going to take me to actually be up and running with this, for like making like at least a test socket for a patient?
Absolutely. So what happens is it's for us for the scanning software. That's where we have contracted out with prosthetics, because here at Filament Innovations, we are a hardware focused company. So our job comes in once you have the model made, the STL file, and then we show you how to slice and print that. So that's where we come in. For scanning and digitizing, that's where prosthetics would come in, and they show you that. So assuming you have the STL file, and that's where we kind of draw a line here at Filament Innovations, we assume you have the STL file. We can train you on how to use the slicer, load the filament in the machine, get the machine on Wi-Fi, heat it up, print it in less than a few hours. Because 3D scanning and modifying, and I'm sure Brent would back me up, is a whole different world. So it's a whole different world to actually be able to go ahead and scan and modify. And that's where we're contracting that type of training out to a specialized company. That's not our bread and butter. Our bread and butter is focusing on hardware and training people in the slicers and the printing of that. But I would say if you came in knowing nothing about 3D printing at all and say, I have no idea what this is, but I have an STL file of a prosthetic socket, how do I do that? We can have you trained in about 3 to 4 hours easily.
Okay. And how about like things like maintenance on the machine and stuff like that? That seems like something could be a bit daunting to somebody who's not used to printing.
You know what? It is, and you're absolutely right. And that's where our 5th generation Icarus, which we'll have updated on the website in a few days, we had a little sneak peek of it at the Academy show. We've made it really easy. We really have. By going to the enclosed ball screws, now the linear motion is completely sealed off. And the Icarus also has enclosed ball screws. So now we have our X, Y, and Z axis fully enclosed, full ball screw linear motion, very little debris, very little dust gets inside. All the motors on the X and Y axis are closed loop. The Typhoon, we share the very detailed guide that Dies Design put together for maintaining the Typhoon. But really, there's only 2 things that require maintenance on our machines. The ball screws should be greased about every 4 to 6 months, depending on how much it's used. But now that that maintenance guide was also for our old model as well, which did not have enclosed ball screws. But now that we're enclosed, we're still saying 4 to 6 months, though, play it safe, of keeping the ball screws greased and changing the fluid in the water chiller, because we're actually using Dies Design's water chiller as well. So we have our water chiller on our new machines is actually embedded into the machine itself, and about every 6 months, that fluid should be changed out. So really, every 6 months, you just have to put a little grease on the ball screws and change the fluid out, and you're good to go. I mean, for really, the maintenance of the machine might be an hour, 2 hours every 6 months. It's very, very little.
Mm-hmm. And this water chiller thing, what does it do? Because it's a water-cooled head, right? Or...
Yes, it is. Yes, the Typhoon is a fully water-cooled assembly. And basically what we've done over the years is we've aligned ourselves with high-quality suppliers. And that's really our goal, is to create some of the best machines possible in the 3D printing world that numerous businesses could afford. And that's where we came into a great relationship with Dies Design. So really, any product that Dies Design creates, I want to vet it, make sure it's good, and they're always good, and we put them on our machines. So really, we're kind of a little, I'll say, showcase for Dies, because we have their Typhoon is standard on the Icarus, which is the water-cooled high-flow head. You have the Sentinel.
No, I just noticed that also, like, if you're looking at I noticed before when looking at one of your printers, you use the high wind, right, on the linear rails and stuff like that.
Yep. So we have the high wind that was on our old version. Now we're not using high wind on our new version, but instead of using high wind, we're now using the fully enclosed ball screws now. So instead of the high wind rail, now we have the ball screw assembly.
Okay, because I'm a huge high wind fan as well. Huge high wind fan.
Mike, I was wondering, like, with the high flow stuff, either on the pellet extruder or the Typhoon, I know you guys have really pushed the limits as far as extrusion width and layer height. How far have you pushed it?
Pretty far. Pretty far. We using the Typhoon with a 2.5 nozzle. We really just stick at a 1 millimeter layer height, and I have no science, no data to back that up. It's just that 1 millimeter is a nice clean number. The layer height looks good. We've pushed that almost to an 8 millimeter wide pass. Now that's running at about 8 millimeters per second, but you're thinking a 1 millimeter layer height 8mm wide pass on a FDM machine is, to me, crazy. But it's crazy.
That's wild.
But if you are doing kind of like a spiralized thing right here, right?
That's correct. With the prosthetic sockets, we are correct.
Yeah, so there it would really, especially if the weight of the thing is quite considerable, it would actually like it calls for better layer adhesion, which I really like about spiral. I was considered like a gimmick, right? It was something to make vases. It's like a vase mode. It was like a joke, and then it ends up being like super useful for a lot of like construction kind of things and stuff that needs to be really strong.
Yeah, and that's where you'll see with the high flow system, where the layer bonding is very, very good, because instead of having tiny layers coming together, tiny lines coming together to create one solid object, we're essentially just fusing large layers together, and we are seeing incredibly stronger parts compared to where if they were made traditionally using smaller lines.
No. It's literally the weight of it and the surface area. And also just the roundness of it, requiring in the melt time you have less time when it's, or more time when the surface area is actually melting to the previous layer, rather than it settling, let's say. So I think that's also really quite interesting to see. But so you're making these things in the U.S. I mean, the 31,000 for a system doesn't seem like a really outlandish price. I mean, it seems like a really reasonable price, really. How are you doing this then? I mean, you mentioned like low overhead, which I think is like the smallest beautiful thing. That's maybe people don't understand why that's so key.
Yeah, I totally agree, because just because my background is not. I've ran numerous businesses before. I actually worked in the tobacco industry before. I've worked for large corporate America, and being my background is actually in accounting and financial analysis. I've seen numbers my whole life. I've seen numbers. I've seen accounting, financial statements. My whole life has just been managing money, working with money, reporting where the money goes. And there's a lot of waste in corporate America. There just is, and I know that because I had to report on that. And so when I discovered out of manufacturing and Brent and working with Brent, and I just said, you know what, I want to run a business where we can be affordable and streamline our manufacturing process. So the people we have here at Filament Innovations, I would be willing to put my team up against any other team that we've come across, because when we hire here, we hire based on passion and work ethic. We want people who aren't necessarily 3D printing experts. We want people who want to learn. They have that drive. They have the passion. They want to show up to work early. They want to stay late if need be. And I would rather put our money into people and personal growth than having some elaborate facility with floor to ceiling glass windows in some corporate office somewhere. I would much rather just have a nice facility we're all happy in with the right people doing the right job.
Yeah, I'm really skeptical of places spend a lot of money on conference tables. If you put me next to a really, if you put me onto a really good conference table, I'll like rub the conference table. I'll be like rubbing it over and down, like, this isn't from IKEA. This thing's huge, and I'm like,
where did this come from in the Amazon? Right? What kind of tree in the Amazon did this guy come from? How much does this cost to get here?
Yeah. Do you feel the same way about foosball tables and other things when you go into places? I mean, I know I sometimes do. It's like, okay.
Yeah.
You spend it where you care, right? Yeah. I think that's me. And do you make them? You manage you just-in-time order stuff. Does it also mean you make, like, if I come to you with the money, to actually like make it to order essentially once I pay you, or how does that work?
That is correct. So we're actually trying to get away from that. So right now, yes. So if you come to us, we have about a 4 to 6 week lead time on the Icarus machine. However, with the Icarus is selling very, very well. Knock on wood, we are moving quite a bit of units. We are going to be transitioning to actually having those in stock now. So instead of having a 4 to 6 week lead time, we're hoping now that once you place an order, we should be able to have it shipped within 1 to 2 weeks to you.
Okay. And what are the challenges? Because like the thing is, like, I know, you try, of course, to make everything made in America, but that's not actually that. That's actually quite hard, because there's a lot of stuff that you can't make in America anymore.
It is. A lot of our we do use aluminum extrusions. The majority of those are from America, from Misumi. Once in a while, they are outsourced to Japan if it's an odd size extrusion. All of our acrylic.
But made in America. What were you talking about just now? I didn't catch you.
Oh, I was saying our aluminum extrusions that we use for our initial frame of our machines.
Ah, like
The
those,
maj-
yeah.
Yep, the majority of those are American made. Once in a while, if it's an oddball size, it has to come from Japan. But that our hardware bolts and our bolts and nuts are from America. Our acrylic is from America. The only thing we're importing overseas on our machines is our ball screw system. So that one is imported from China, as well as our stepper servo motors that we use. They are lead shine motors. They do come from China as well. Beyond that, it's the majority of the machine itself, hardware, nuts and bolts, is all American made, American sourced.
Is there even like an American, because in Europe you might want to use like Bosch or X-Road or something, as steppers, right? Or as servos, right? Is there even a solution in the States to have like a really high quality stepper or servo you could use that is even made in the States? Does it even exist?
I, and that's the issue with that I have. And I agree with you. I don't know of many companies that unfortunately make certain electronic equipment in the USA. And I'm sure they're out there. I'm sure people will say that they could help us out. And if anybody's listening to this and they do stepper servo motors here in the USA, we would love to work with you, because our goal is to do as much American manufacturing here in the US with our machines. So if it's out there, I'd love to work with them.
Yeah, definitely. I know there's like really high end motion control systems like these, the air bearings, that kind of stuff, PI or something. And these guys, there are some of those guys in the States, but that's like mega high end stuff.
Right. And our thing is too, we do spend quite a bit of money on linear motion here and that's, that definitely affects the price. So, like everything else we do, we have a certain budget to work in, but our motors and our linear motion system, we definitely pay a premium for. So hopefully if we could find a USA alternative, we'd be more than happy to, talk to those people.
Yeah, well, definitely. I know there's like ultra high end stuff for satellites and stuff they do in the States, but not, anything below that I wouldn't know if there's Bosch or Exoth in Europe, but that's not relevant for you guys, I guess. But and do you do a lot of the tooling and manufacturing in house? What do you do in house? Do you do a lot of CNC and stuff like that, or just assembly, or?
We do our laser cutting in house, our wiring in house, and our assembly in house. We do outsource our water jet to a company called Aquajet. They just moved down to Reading, Pennsylvania. Great bunch of guys down there. They do all of our water jetting for us.
Mm-hmm. Okay. And you guys are like in Allentown, which is like, it doesn't seem to be like the really, to me, be a very expensive city. Is that like key because you can afford to be there and your employees can afford to be there as opposed to
exactly. It's funny you say that because we tell people we're from Allentown. We're actually in a little tiny town called Copley, Pennsylvania. It's about 20 minutes away from Allentown. We just say Allentown because that's what people around here know. We're actually in the middle of a farm. I'm actually looking out the window right now and I'm seeing hills and corn and everything and fields. So we're not in any industrial area. We are in a full-blown rural area. We have deer around our shop running around. We see deer every morning. We're definitely not what you'd expect for a additive manufacturing company. You would think big industrial, big complex. No, but instead we're out in farmland, Pennsylvania, and I think I love it. I love it that way. A lot of fresh air, wildlife floating around. We can open the bay doors, have a little barbecue, see some deer running around. So it's an awesome environment to be able to build these machines.
Yeah, I guess, but that's an environment that makes sense, right? Like some cool, like Williamsburg or something. That's not going to make sense, being in New York or whatever. Then the economics just don't add up. I mean, that's why I'm a bit skeptical of 3D printing companies located in New York. Always was. How many systems do you sell? Right? Just give us an idea what size you are.
We have right now about 150 units in the field right now.
Oh, sorry, I didn't catch you.
About 150 units in the field right now.
Oh, okay. That's much more than I expected.
People, that's that. Yeah, we kind of keep everything kind of low key with Filament Innovations. We don't, we really don't talk numbers too much. But my wife and I, we started this company back in 2015 with $10,000. We put our life savings on the line, and we've, I'm not trying to toot my horn here, but I got to be honest. We have no outside investors. We have no grant money. We have nothing. It was just my wife and I back in 2015. We had 10 grand. We went all in on the operation, and now we've grown, we've expanded, and so it's to me it's a lot. I know there's a lot of businesses in the additive manufacturing. They get these rounds of funding and these millions of dollars of investments. And I get that. It's just for me as a business person, I feel there's more on the line to lose when it's your own personal money being put up to finance everything. It kind of just pushes you to go the extra mile.
Yeah. It also gives you a lot of like, like you're your own boss. Let's say you're really your own boss. You're not looking at someone who's going to get out of the business in 3 years.
Right. And we're definitely in it for the long haul. And so, taking that step back and realizing where we've come in the past 7 years from $10,000 to where we are today, knowing with no investors and no grants, and we've really clawed every step of the way we've taken. We're definitely proud of what we've done, and we just want to keep innovating and keep working as hard as we can to keep pushing this industry forward.
Awesome, dude. And Mike, I really love your printers. Really love what people told me really, really good things about them and stuff. I really love what you guys are doing. And thank you so much for being on our podcast today.
No, thank you so much for having me. I really appreciate it. I don't get a chance to do many podcasts, so it's great to be on and help talk about Filament Innovations and some of the partners where we're working with. And I have to, if you don't mind, I have to give a special shout out to Brent too, because I always say the same story. I would not be here unless Brent bought one of my first 3D printers. And I mean that because he's the one that single-handedly showed me the world of prosthetics. He showed me this idea of prosthetic fabrication back in 2015. And he's been such an integral person helping me grow Filament Innovations and introducing me to the O&P world and the processes out there. So Brent, from the bottom of my heart, honestly, man, thank you for everything you've done.
Yeah, man. Well, no, I appreciate you coming on and sharing some of this new stuff, and keep on pushing hard and into the space. And I'm super excited where you're going with this. And I think between the hardware and some of the filament stuff, you got a lot of good things going. So thanks for being on here.
Yeah, and thanks a lot for everyone for listening this time. I thought it was a great episode. Really enjoyed it. I hope you did too. And thanks for being here, Mike. Thanks for being here, Brent. And thank you for listening. Have a great day.
Thank you so much.